Have you ever noticed a crack in a building and wondered, should I be worried? Not every crack means a building is unsafe. Some are minor, but others can be a warning sign of a deeper problem. So, why do buildings crack? Let us understand the real engineering reasons. The first common reason is shrinkage. Concrete, mortar, and plaster contain water. As they dry, they can shrink slightly. But if the material is restrained from shrinking freely, tensile stress develops. If that stress becomes too great, the surface can crack. Good mixed proportions, proper workmanship, and adequate curing can help control this type of cracking. The second reason is temperature. When materials become hotter, they generally expand. When they cool, they contract. If this movement is restrained, stresses can develop. That is why engineers provide movement or expansion joints in appropriate structures. These joints allow control movement and help reduce unwanted cracking. Now, the third reason is foundation settlement. Every building transfers its weight to the soil through its foundation. Some settlement can occur as the soil responds to the building load. But the bigger concern is differential settlement, when one part of the building settles more than another. This uneven movement can produce cracks, sometimes appearing diagonally around doors and windows. But remember, a crack pattern alone cannot tell us exactly what caused it. Now, the fourth reason is structural loads and movement. Buildings are designed to carry loads. These include the building's own weight, people, furniture, equipment, wind, and, where relevant, earthquake forces. If loads change significantly, or if there are problems with design, detailing, construction, or later alterations, excessive stresses can develop. Cracking can then occur in structural elements such as beams, columns, or structural walls. For example, removing an important structural element can change the way loads are transferred through a building. That is why structural modifications should never be made casually. Now, the fifth reason is corrosion of steel reinforcement. Steel reinforcement is normally protected by the surrounding concrete. But when moisture and other aggressive agents reach the steel, corrosion can occur. The corrosion products occupy more volume than the original steel. This creates pressure inside the concrete, which can eventually cause cracking, delamination, and spalling. Cracks accompanied by rust staining, exposed reinforcement, or concrete spalling deserve particular attention. So, should you panic whenever you see a crack? No. A small surface crack does not automatically mean that a building is unsafe. But cracks that are growing, significant, associated with water leakage, accompanied by spalling or exposed reinforcement, or located in important structural members deserve attention. If you are concerned, have the building inspected by a qualified structural engineer. So, why do buildings crack? Shrinkage, temperature changes, foundation settlement, structural movement, and reinforcement corrosion. A crack is not the diagnosis, it is a clue. And in civil engineering, understanding the cause is more important than simply looking at the crack.